The mic? Ah, wow, that's creepy. All right, good morning, everyone. I'm gonna start now. I know people are still coming in, just do it quietly, but I want to be respectful for the people who were here at the allotted time. So, good morning. Today I want to talk to you about excitement. Remember this? As a child, you go to school, you learn new stuff, and you go home all excited, like, hey, I did this cool stuff at school. And this excitement is actually what I enjoy most about my job. So I'm a software consultant for InfoSupport, a company in Belgium. And as a consultant, I really take a lot of pride in delivering a good solution. And I get really excited about the stuff that I delivered. For example, one thing I got really excited about recently is we got asked to make a proof of concept to read a smart card. So in Belgium, the identity cards are smart cards. And we had to connect to that. And I was like, oh, I'm going to have to learn some C++ or something. And then it turned out, and this got me really excited, that Java, so without any libraries, has modules and packages to actually read a smart card. And I went home all excited, a bit like this, and told my wife, I'm like, hey, look at what I did today. So that's the kind of excitement that I love and enjoy in my job. And that's, I hope, the excitement that you get in your job as well. But unfortunately, those are the really good days, and those don't always happen. Sometimes there's production issues, conflicts at work, whatever. And if you have a really bad day, then you can tell about it in sessions like this. I don't know if you know these two guys, but it's Oleg and Roberto. And every year, when Oracle Code 1 was presented, they do this session, which is development horror stories. And the development horror stories is basically, it's not a session like this where one person talks, it's more a collaborative session. And everyone who has a horror story can come up and come tell it. So there was a story about someone accidentally walking into the wrong building and shutting down the wrong data center, which is tricky. But and they always have some kind of award ceremony for like the worst disaster. And I was there in 2018, and the horror story that won that year was a story of someone who worked in a hospital, and they did STD tests, and they send out mails. Can you guess where this is going? They send out mails to everyone who was positive with the STD, but they forgot a where clause. So it got sent to everyone. Now, if that isn't a horror story, then I don't know what is. Now, if you think about it, that could have been avoided, because forgetting a where clause is something that you should be able to see before you go live. But it didn't happen. So normally we write tests to save us from those kinds of horrible situations that I hope that we never end up in again, and I hope that you never go to those sessions and win that award, which is not really an award you end winning, to be honest. But we write tests to help us, both to help us write better code and to verify that the code that we've written actually matches what we expect, but also we write tests to give us more certainty that it will work in production. I put more in red because there's always things that you can't help. For example, walking into the wrong building and shutting down the wrong data center. I don't know what kind of test you're going to write for that. So there's certain kinds of tests and certain kind of issues that you could solve by writing tests. But I get more and more the feeling, because I'm a consultant, so I see a lot of different code bases, that the way we write tests, I mentioned in the previous slide, it's to safeguard us from issues. But I get the feeling that more and more tests are like this, like they're fancy, they look nice, it's green with a bit of blue, it's nicely painted. But when you think about it, this fence does nothing. So you can just walk by it and it doesn't do anything. And I get the feeling that a lot of tests that we write are actually quite a lot like that. So that's what I want to talk to you about today. Investigate a bit, I have a few stories that I'm going to tell, and investigate a bit how we can write better tests that give us more security, and don't write tests that give us a nice feeling, because it's a nice picture, but actually don't help us a lot. So that's what we're going to do today. just a heads up, I said I'm a consultant, so I'm going to talk about a few test frameworks. I'm not affiliated with any of these test frameworks. It's just things that I like to use and that I want to share with you today. The first story I have is, yeah, I could have picked any picture of code, but I was in a company that I will not name, of course, and they had a brand new manager, like recently graduated, instantly manager position, had never looked at anything IT but was suddenly an IT manager. And they were really grasping to get some control because the teams weren't, well, the software was full of bugs. So they tried to figure out something that they could like manage. They needed a number to focus on and to point the teams, you need to reach this number. And when we write tests, can you guess what that number became? Coverage, exactly. So this person decided, hey, teams, you all need 85% code coverage. Congratulations. Can you guess what happened? No? What you saw is that there was one team that had like 20% code coverage, which is a big red flag, but it is what it is. And if you would draw a graph, it would look a bit like a crypto scam graph. It went directly to the moon. As soon as they said, oh, you need 85%, whoopa, they suddenly had it in a week. Now, when something goes up like that, I sit in amazement and wonder how, even how did you do that? How did you get so much coverage? Well, I've named this aptly test for coverage, because these are the kinds of tests that I saw. So they spend an entire sprint writing these kinds of tests to get more coverage. But that wasn't the worst yet, because what we also saw was this. So, manager says we need to get 85% code coverage. Congratulations, we have 85% code coverage, but yeah. I have to be honest, the comment wasn't really there, but in spirit it was there. So this is useless. So what is something that you can do to stop this, or at least to signify it? Because to be honest, this was really done on purpose because a manager said so, but code coverage is a tricky beast because you're not quite sure if it actually is valuable. And that can happen to any of you as well. You think, oh, code is covered, but we're missing important paths. So what you can do to solve this, or at least get some insight in this, is something called mutation testing. So who of you is aware of mutation testing? Please raise your hand. Okay, quite a few, a lot of people not. So let's dive a bit deeper. So imagine you write a test. Well, you have some code. Let's start with that. So I have a simple method where, we check if there's bikes available in like a bike rental system. What you do with mutation testing is you change the code. Well, you don't change the code, the mutation testing framework changes the code for you. And it starts mutating it in different ways. So for example, here, it creates 3 mutants, and it changes this method implementation from a bigger than and equals to a bigger than, a smaller than, and it just throws away the entire statement and returns true. Why would you do that? Well, if none of the tests fail now, that means that you haven't covered those paths. So in mutation testing, it's called killed or survived. So either they spawn a mutant, they spawn an extra method like this, or a change in the method. And when a unit test that you've written fails, it means that it's killed. You killed the mutant. But if the mutant survives, that means that any developer in your team could basically, for example, take the bottom one, could change the implementation to true, and none of your automatic build pipelines would fail. And that's just dangerous. So I ran that quickly on that one method that I showed you before. Let me see, it should be in here somewhere. Oh, no. Oh. And if you run it, then you get a nice report like this. Let me just zoom in a bit. And the class I was testing was this one. So you can see, hey, they reached the 85% 100% line coverage. But if you look at the mutation coverage, so that's the amount of mutants that were killed, it's only 20%. So this can give you a good insight. If these two numbers differ quite a bit, it means that yes, you have the line coverage, but it might just be useless because you're not actually asserting things, or tests aren't failing when the code is changing. And you can click through a bit, and then you get a nice detail of the entire class in which things are tested. Like equals and hash code are not tested because we don't do that because it's too difficult. If I have some time, I will show you how we actually do test those. And you can see it generated a bunch of different mutations. For example, it replaced a Boolean to return false instead of actually an implementation. And those are not killed, and then there's a few down here that did get killed. Now, this test framework is smart enough that if there's no coverage on those lines, it will not generate any mutants, so it's not like wasting your time. And this gives you a good insight in which things are covered correctly and which things are like fake covered. Like you have coverage, but it doesn't actually mean anything. So what is this framework called? Let me just switch back for a second. Oh, I'm messing up my presentation order. It's just here. So you have two test frameworks. So PiTest is the one for Java and Kotlin. That's the OG, let's say, the original. But at Info Support, I talked to my manager about this, and he said, you know what? We don't have this in .NET. We don't have this in JavaScript. We don't have this for a ton of language. We don't have this for Scala. So that's where Info Support decided, so the company I work at, we're going to take some of our consultants, we're going to give them some time, and they're allowed to work on a mutation testing framework for JavaScript, Scala, and the other languages. I'm not here to sell it. I'm just excited for you. It's completely free. Please check it out if you think mutation testing is something that can help you. And one of the things that I really noticed while consulting and even talking at schools is that there's a lot of focus on the testing pyramid. I don't know, who was in Kevin's session, the first slot today? All right, so you already know this part, but the testing pyramid needs a certain context. The context was that integration tests were just way harder to do before. So as they become easier, you might decide to shift your pyramid a bit. But still, I noticed that in a lot of schools, we focus on this. Write a lot of unit tests, make sure they're fast, make sure they're isolated. And the more that we focus on that, the more starting developers I get that come into our company and that basically do stuff like this. So for those that don't recognize this, this is a Spring Boot test. It's calling the repository. So the repository is normally your data connection to a database. And I see developers mock this. They mock it. They say, hey, if the find all is called, return me some stations. And then I test if this method actually returns this. And if you look at the method implementation, this is a lot of code to test this. And nothing useful happens. It's basically just a password. You basically just tested your mock itself. So I think there's a bit too much focus on the testing pyramid. So that's why I want to talk to you about some of the other testing tools that can make it easier to write integration tests, so you can do better tests that are maybe a bit slower, a bit more integration, but give you way more value than, honestly, a useless test just for code coverage. So let's get to it. Let's look into improving the database tests. Because one thing that is already a bit better than mocking away your repositories is using the H2 in-memory database. Who uses H2 for their tests? Quite a bit of people. Okay. So the H2 database is an improvement over the mocks, because in a way, you test way more. You already test your JPA part. You test your mapping part. But one thing that I find a bit annoying about H2 is that it's an in-memory database and not a real database. And does anyone know what happens when you start a test with H2? Because it's an empty database, so how does it fill the database to begin with? You could say Liquibase. That's a slight spoiler alert, but so H2 will just look at your bean mapping. So if I look at this, it will see, oh, it's an entity, and it will create this in the database. So it will do it automatically. Do you know the default mode in Spring? Oh. Does anyone know the default mode on how it does this? Yeah, it just creates it and it drops it. Or it drops it and creates it. Because it's an in-memory database, you don't have to care. But you could do the auto DDL, so automatically provisioning your database. You could do that from your code. Just like you do in your tests, you could do that in production. But you can't just do a create and drop or a drop and create in production each time. If you can, kudos. I would love to work on your system because that makes life a lot easier. But you often need to iterate and like make small patches. And this is something that I really miss in our tests as well, because we base ourselves on these H2 in-memory database tests, and we try to test against it, but actually the updating of the database is never really considered because H2 and those bindings do it automatically. So that's where something like Liquibase comes in. Who knows about Liquibase? See, quite a lot of people. So just for all the other people, Liquibase is a database migration tool or a way to update your database but then script it. So this is usually how you deploy database changes into production. Instead of letting Hibernate take care of it automatically, you script your files and say, hey, I want a table to be created, I want this constraint to be added. So I used Liquibase for this, and I'll give you a short walkthrough. So you have a change log where you list all your different changes. I have made a horrible life choice by picking YAML, because it also supports XML and SQL directly. And this points to a bunch of different migration files, and here you can list your table definition. Table definition, and that gets applied to the database. So why do I like using this? Well, because instead of doing the auto DLL part where your H2 gets provisioned based on your code, it actually does it now with Liquibase. But it's a trade-off that you must be aware of, because the trade-off is when the H2 starts, it can provision your database pretty quickly. But when you use a Liquibase, it needs to apply all those files one by one to set up your database. And that can become a bit slow. Okay, unless if I talk a bit and then time flies. So let me just see. Here, right here, it says which change set it ran. And you can even blame someone in case the script goes wrong. But in this case, yeah, it loads your database pretty quickly, but that's because my list is short. But I can, for example, add a constraint like this, and now when I run my tests again, it will fail. And why does it fail? Because, yeah, I added a constraint, and hey, yeah, of course my tests fail now. But the fact that I can already see these things in my tests, because I use Liquibase in my tests as well, it gives you an advantage because you can quickly see, hey, where did I make a mistake? Are these scripts even working in the order that I expect them to work? And we could change that, but I'm not going too deep into that right now. So what you could do, maybe a quick question. Who uses Liquibase in their tests as well? Okay, a few people less than. Have you ever run into the issue that you have your tests, you run Liquibase, but then when you try to run Liquibase on your production environment that it fails because of something? I see a few people nodding yes, so that's good. So there is a trick that you can test that as well, but it requires that you get a database dump. And that looks something like this. Because Liquibase has something called context, and you can decide to run scripts within a certain context, then fill your database with something, and then run the rest of the scripts. So in my example here, the initial setup has no context, so that just runs. But the add constraint, I added a context of new, just for demo purposes. This could be a release version, could be something else. And the way you can do your update test now is, hey, run anything except a new context, load a dump. I don't know how you get it, but it's a simple way to do this. And then run the extra context. And in this way, even if there's data that's incorrect according to your new constraints and the scripts would fail, you can already write a simple test for it. So usually we don't put this one enabled in the build, but we just label it as disabled. And then whenever we need it, we just uncommented it for a second. So we have a few disabled tests in our build setup that don't run every time, but they're there for quick use if we ever need them. So that's one of the tricks you can do. By the way, if you use H2, but you already know that you're going to use another database in production, there's something called these compatibility modes that you can add to your data source URL. And then H2 will actually try to mimic the database as much as it can, within reason, of course, because it's not the real database. So for example, an insert into with an onConflict do nothing is something pretty specific to Postgres. But this way, by enabling this mode, the test will actually pass. So that's one way to improve that. All right, so this is just for reference, by the way. You get the slides afterwards. So for the H2 in memory, you get the AutoDDL setup. It's convenient, but yeah, it assumes that your database will kind of be the same, and it's still not the real database. And then we use Liquibase to improve it. So your tests are still quick, a bit slower because Liquibase needs to run all the scripts now. And it's still not the real database. And that's where we come to test containers. Because if we want a real database, it used to be quite the hassle to get a real database going, because it meant running an extra script that would start the database before your test set, and there's a whole ordeal. But luckily, there's now the test containers library. So who knows about test containers? Oh, look, quite a bunch of people. So I'm going to give a short intro, and then I'm going to dive into a few more advanced topics for you then, because I see a lot of hands up. So with test containers, it's perfectly possible to, I now have the same test that I had before. So the one that will actually connect to a database, but instead of H2, it's connecting to a test container. So this is a PostgreSQL container. This is a special class that the test container library provides for you, because you could put some specific properties for Postgres. So you have a different, well, this is the way you can start such a container. Cool thing is, you can list a specific version number. So if you have such a test and you're planning to upgrade your test, your Postgres database, you can also use this test to quickly change this into a 12 and see if all your tests still pass. So that's also a cool use case for that. But then, since we're in Spring, this is a really specific Spring example, Spring has loaded your properties basically on startup, but now you're starting a test container in a test. So that's like a timing issue, because you don't know at what port this container has started until it started. So Spring luckily provides a dynamic property source for this. And this Postgres SQL container class provides a few getters that make it easy to get like the JDBC URL, so you don't have to type that yourself, you can just use a getter. And this way you can enable certain properties or change certain of your Spring properties after Spring has actually kind of already started. So I suggest that we just run this one quickly. So this is a pretty simple test. It just, in the setup, it dumps a few stations. That's where you can put bikes in like a rental situation, and it just gets the list again. Oh, it's already started. As you can see here, has these cute little Docker wheels. So you can see, oh, come on, I was showing the Docker wheel. So whenever something happens in Docker, you get this cute little icon. So it's really clear when something is happening with Docker, because test containers actually needs a local Docker. No, I'm saying that wrong. It doesn't need a local Docker. It needs a way to run the container. So that could be Docker, it could be something else. And you can see here it's creating a new image for Postgres 11.1, and it starts the container, and then it started in like 2 seconds. So by waiting 2 seconds for this database to start, you can have a test against the real database. So that's the trade-off that I wanted to talk to you about. Your test is a little bit slower than the H2, that's true. But on the other hand, you get to now test against the real database and everything that entails. So if there's special quirks that might happen, you get to see that quite clearly here. As you can see, the test pass, what happens here is, it just starts the database, it starts running my Liquibase script, same as always, and then it runs the test. Actually, nothing too special. By the way, there's one thing you should know about this. It's static, and that feels a bit weird to put static stuff in a test. This annotation will take care of the life cycle of this container, so you don't have to worry about it. It will start it automatically and stop it automatically. But when you make it static, it actually keeps the container for your entire class. If I remove the static and I have multiple tests, it will start a container for each test, and that's maybe a bit overkill. So what we usually do is we put it static, and then to make sure that there's no issues between tests, we have like a small cleanup script to fix it if we need to. Or use different schema, or there's different approaches. But just be aware that if you make it static, it stays the container stays up for the entire test. So that was the intro part, let's say. What are some other cool use cases that we use these test containers for? Well, have you ever seen those? Maybe it's a dev horror story as well. Have you ever seen a tweet where there's suddenly someone saying, "Oh, we got our bill from AWS, and it's a bit more than we hoped." Like I saw someone get a bill for like, what was it, $25,000 because they accidentally connected their test setup to actual AWS. So that's not good. That's really not good. But there's a way to avoid that, because cool thing is, TestContainers actually has support for a local stack container. So this is a specific module within the test container library, let's say, that allows you to run local stack. And local stack is a fully emulated AWS environment. So for example here, I run a local stack container, and I can say what services I want to run. So now it's just S3 for this test, but if I look here, you see that they have a lot of emulated services that you could use. So instead of, what I often see is 2 things. Either people take the hit and pay for AWS to run their tests against the real AWS, but that costs a lot of money. Or I see people who mock away anything that has to do with a cloud vendor. But the second part is also really dangerous, because if you mock those integrations away, you don't know if they're actually going to work when you deploy them. This is for us the ultimate middle ground, because you get to test against an S3 service or any of the other services. And the cool thing is, I don't know if you recognize this, but this is just the official AWS client. So you don't have to change your code. It uses the official AWS client to connect to that local AWS, for example. So this is like a real big money saver if you use it that way. That's one thing I like. The other thing I like has to do with errors, because I personally think that we need to test a bit more for error cases, because the more that we're starting to distribute our systems, we're calling more and more API calls, we're connecting to more and more databases, but we forget that there's network in between. And network is, I don't know how it is here in Sweden, I think you had fiber like one of the first countries, but I'm from Belgium, and I remember the old dial-up days, so networks are a bit flaky things. But we never test for that, because it used to be really difficult to emulate network failures. But by using something like Toxiproxy, that becomes pretty easy. So what's Toxiproxy? So when you do these things in test containers, you're spawning different Docker containers. But if you are a bit familiar with Docker, then you know that you can combine multiple Docker containers into a network, and then they can talk to each other. That's actually what's happening here as well. So you have, I have a simple container that I built myself from a Docker file. So if something in test containers doesn't exist, it's pretty easy to just refer to a Docker file and then it will build it for you when you start running it. So whatever code you have, you can dump it in, and whatever code you have that can run in a Docker container, you can run with these test containers as well. And I connected it in the network with something called Toxiproxy. And Toxiproxy is a library from Shopify, one letter difference. And that actually makes sure that you have like a little proxy. So you have your app, you have the proxy, and then the actual thing you're connecting with. And that proxy is like this toxic ball of potential issues with your network. And this toxic ball, you connect it like this. I'm not going too deep in the code. All code will be available for you to inspect and at your own time. But you can add toxics, and toxics are like these network issues. And one of the network issues is, for example, latency. So in this case, I have my app that's connecting to an API, and I can add some latency, for example, some jitter. So that's randomly a bit more latency, a bit less latency. And you can even choose which direction it is. Is it when the data comes from the remote server back to my server, or is it when I'm pushing some data to the server? Is that the issue? So both ways. So if we quickly run this one, I have a repeated test, so you can see it 10 times. It's not like official that it works perfectly, but at least you get a sense. So the first 1 or 2 tests you can basically ignore, because then the server is actually still starting up, but it gives you a pretty good impression. So you can actually really see the jitter here. So I had a jitter of 500, and this one is, I know it's a little bit small, but this says 15 milliseconds response, and sometimes it responds only after 300 milliseconds. So by introducing something like this Toxiproxy, you're able to test these more difficult use cases of network errors. This is also really useful if you have a bug in production. It's, oh yeah, it was because of network, then you can try to reproduce it locally as well. I have one more, and this is a bit more exotic, because one of the comments that I usually get with the previous part, the Liquibase, yeah, but what if your changelog gets really, really long? Because then your tests become slower and slower because it needs to run this entire set. So there's something you can do, and I actually haven't validated this if it's actually allowed with anyone from TestContainers, but Kevin's here, so we'll see what he thinks. He's right there. So what you could do is start a container that you've created yourself that's based on Postgres. And then whenever someone pulls something to the develop branch or the main branch, you can run this one. It will pull the latest version that it knows, like the latest dev version. It will run Liquibase, but because you pulled the previous version, it only needs to run the new scripts from that branch. And then you can do something in Docker called commit. And commit means whatever Docker container you have running now, commit whatever changes into a new image. And then you can push that new image back. And by doing this, you have a Postgres container that actually contains all your database changes that have been merged to your develop branch already. So in this way, you could really reduce the time it takes for all your tests to run those Liquibase scripts, because they take longer and longer and longer after a while. So that. So pretty cool stuff. So you get pretty accurate performance. I have to say the pretty accurate performance is a bit tricky, because if you're running your test containers on the same laptop, then of course there's a bit of performance hit, because if you're running a big Elasticsearch cluster with test containers, then yeah, your tests aren't going to perfectly be performance accurate. But there's a solution for that. For example, you don't have to run the Docker containers on your own laptop. You can have a Docker host somewhere else and then connect to that Docker host. And there's actually a beta service right now from Atomic Jar, the guys that are maintaining test containers, that allow you to connect to a cloud environment where they run the containers for you, and all your test is doing is connecting to those servers. So if you have a chance, harass Kevin so you can sign up, and then you can test it out for yourself. But using this setup with test containers, you get cool stuff. The startup is maybe a bit slower, and that's the trade-off I'm talking about. So that's due to Liquibase and the test container starting, but the value that you get out of your test is way higher. And yeah, it requires some external software. So we can also improve API tests this way. So if you're lucky, you have something that's already Dockerizable, like for example your own API, and then you can test that external service by running your own test container. So for example, if you depend on a service, but you already have a Docker container for it, then you can use test containers to spawn that Docker container, and then you can test it that way. But that's unfortunately not always the case. When you have an external API, you don't always have the resources to run it yourself. But there's a different way to solve this, and that's using WireMock. Who's aware of WireMock? Quite a bit more people. Okay, then I'll go a bit quicker. WireMock is a tool to basically conveniently start a server that you can connect to. So that's usually a REST-based service. And if you want to learn more about this, I know Ishel is talking about this afternoon as well. So what does it do? It basically starts a server, and you say, hey, if you go to the / endpoint and you get it, then you can return something that's in a file, or for example, this body. And then it will spawn a server on a separate port, and then you can connect to that. There's a bunch of different cool stuff, but since most of you know it already, I'm kind of going to skip this, because there is a bit of a problem with I talked about this. There's a bit of a problem with WireMock. And that's the first negative point. You need to keep that up to date, because if you depend on WireMock in your tests, for example, in a microservice environment where things are changing quickly, it's difficult to keep those mappings, so those stubs, up to date. And that's tricky, because if you depend on a sort of API interface that no longer matches the real deal, then you're still going to fail in production. So what I see a lot of teams do in microservice environments is test by contract. Has anyone heard of contract testing? Quite a few. Okay. So what's contract testing? I just move here. I will be using Spring Cloud Contract. So imagine you have two teams. They have to agree on something, because if two APIs want to connect with each other, they have to agree on a contract. And usually we use something like a Swagger file to describe the API interface. But that's not really that convenient, because it's just documentation, to be honest. So what would be more useful is that if we have something to define a contract, but then you can generate both the stubs for the one who is going to use it, so they can start building immediately, and the tests for the one who's hosting the API. So you can do that with Spring Cloud Contract, and you can define a contract either in Java. So for example, this is one where you say, hey, if I do a get call to /velo with a certain number, I want back the slots and the bikes. So this is a contract. If I do a call, then I want a certain response. If you agree this, then you need those two things, because the team that is going to call your API wants to start building immediately, and your team who's building the API wants some tests to verify if those things that you're promising in the contract actually work. But we have this contract now. And what you can do with Spring Cloud Contract is convert whatever you've written here to those stubs and those tests. Just give it a second. So it's compiling some Java code now. And you can actually see here in my target folder that it created some stubs based on that contract. And if you know WireMock, Then this one should be familiar. Because what it does is it takes those contracts and it creates WireMock stubs for you. So you don't have to program WireMock yourself. By using these contracts, you get all those mappings that you need to make your test based on those contracts. Now the cool thing is, that's one side. You can give these mapping files to your consumer and they can start consuming. But you also, and this is quite crazy, as the builder of the API, who's also agreed to the contract, you get tests. Also takes a while to compile. There we go. And it has generated a nice test class that actually verifies the contract. So instead of writing a Swagger file, which is just documentation for most part, you write a contract and both parties benefit. Both the person, well, the people who are going to use the API and the builder of the API get some automatic tests to verify this. It's quite flexible. You can even make it extend custom class you make for like whatever you setups. For example, this contract verifier base actually starts like some different classes. So it is possible to customize these generated tests a bit. So that's test by contract. What does this do? Well, it really encourages you for some upfront design. So before you start building your complex API, sit together with whoever is going to consume it and make sure that you write such a contract first. The big benefit, as I said a couple of times now, is it generates both your tests and the stubs. So both people, the consumer and the producer, can start working immediately. And it is possible that if you have different consumers, so multiple different parties that will use your API, you can actually make different contracts. So for example, if Kevin wants to call my API and he only needs 2 fields, then we can make a specific contract for him. And when someone else in the room wants to make another API, we can make a different contract that gets 2 different fields. And then when I, as the producer, change one of those fields, then I know which consumer I'm breaking, which is quite powerful if you have a lot of different consumers as well. It's a bit more complex to set up, and both the consumer and the producer need to agree on this, this way of working. Now, I didn't actually show you how the consumer gets these stubs, and that's actually something quite cool in Spring Cloud Contract. Because how do you normally share like jar files and such? How do you do that? Maven, yeah. So Spring Cloud Contract has decided, well, if we're using Maven already, why don't we use Maven some more? So when you want to run a stub as a consumer, you can use this auto-configure stub runner. And this is just pointing to a Maven resource. In this case, my local M2 repository. And it will download the jar file and it will start the stub server in that way. So you don't have any complex sending those JSON files to the different team and they need to load it into their Git repository and so on. It gets taken care of by Maven this way. All right. So that's kind of what I wanted to talk to you and show you. I hope I've inspired you a bit to take a step back, take a bit more time. Maybe it's good that your tests take a little bit longer if they offer way more value. It's really a balancing act. It's not, what really annoys me about that testing pyramid is that it's sometimes dumped on people and said, you need to do it like this, and then people start to apply it like that because that's what they've been told. So be really careful with that. Also, I see a lot of conference speakers using the H2 database, and that's perfect for demos and for quickly continuing when you're trying to implement something in a demo. But take a step back when you actually do this for a production software and think, is this H2 really good enough, or should I be moving to something better that tests more, that will show me the issues that I will have if I run on the actual database or the actual API. So that was the fence. Think about it, take a step back and see if you're just not making pretty tests that actually don't give you as much value. So if you take anything away from this talk today, be constantly on the lookout on where you can improve your tests regarding to cost benefit. If a build takes 2 seconds longer because you're booting up the real database or a real API, that's probably worth it if you discover a lot of issues and integration style complexity that way. So look into that and really improve and see what you can do. Because I hope seriously that by thinking about it and writing better tests with these kind of frameworks, that you never end up having to give a talk at the development horror story session, and that you end up every day going home as a happy, excited developer. That was the talk. So I have this website where I dump all my slides on. It has all the references to documentation, to my code. What else is there? Oh yeah, I also list a Q&A on there. So if we have a bit more time for a couple of questions, if you have any. But if you come afterwards, you ask me questions, I will add those to that page as well. So it should be a valuable resource for you. So any questions, remarks? No? Silence? Yeah, sure. Okay, so when should you run mutation testing? Because it takes a lot of time, that was the question. We usually run it not in a build that breaks. We run it at 2 phases. One for the developer themselves to see, did I write my tests correctly? Because it gives you good feedback. And yeah, it takes a little bit, but you go get a coffee or something at that stage. It's really like right before you do a commit. Or we sometimes run it nightly, but it doesn't break anything. It's just to get an insight. What's the discrepancy between our line coverage and our mutation coverage, and should we do something about it? Anyone else? No? Okay, then I hope. Oh, yeah, sure. Okay, so the question was, if you use something like Toxiproxy, doesn't it make your test indeterministic? Yes, it could, but we use it mostly to try to reproduce bugs in production. So if you see, if you really notice that some connection library, your thread pool is being starved or something, that's really hard to emulate unless something's actually breaking. And then we write a small test like that. And we usually don't throw those tests away, we just put them on disabled and write, hey, if you have an issue, please use this test. Anyone else? Okay, then I think we can quit. I have some Belgian chocolates, but there's way more people here than I expected, so first come, first serve, and then hope to see you around. Feel free to come up to me and chat a bit.